A golf ball on a carpet, recorded the motion with an iPhone, used the video to create a log of positions with Tracker. All new stuff, so I was quite surprised how well it seemed to work. Here's the screenshot of the Tracker program. I'm not going to show the video, but you have already done this work, so you know exactly what we're looking at. The points to call out here, one, that I didn't bother to invert the video since we were looking only at motion in the x-axis. I had to make minor adjustments to set the origin. I think, as most people have experienced, it's hard to get the origin exactly at 0, but that's not actually a problem. Amazingly, low light conditions got a video from which 22, I think it was, frames could be recorded usefully, even though, as you see, the moving ball is a bit blurry, but it seemed to be easy to get the center of mass. The stationary object in the background is another golf ball placed there for reference. I use that as the meter stick because the golfing manufacturers have specifications. So I took those specs off the web and said that's the diameter of the object. Took those data and used the program that we were instructed to use, the Python vidle program, and here's what the output of that was. So, and this would be the predicted rather than the actual velocity. So that, as you recall, it uses the first frame to predict what the velocity will be for the remainder. And that seemed to run fine. I then took the, answered this question: what would happen in Tracker if we made a different choice about the orientation of the axes? And my thinking, my hypothesis is that this is what would happen, that because the default axis is from left to right, and that's the way my video ran since I didn't invert it, the object moved from left to right, so that was in the positive direction. If I had either inverted the video or put the axis inverted the axis, I would have had the displacement going in the negative direction at the same rate. Here's what the data looked like as an Excel spreadsheet. That was interesting to me, that the data in Tracker looked as if it had 3 significant digits, but when put in Excel, actually it has, I don't know how many, but it certainly filled the cell, and I decided that we didn't need more than 4 significant digits, and that cleaned up the table so it was more interpretable. But as you see, then I get a relatively clean looking data entry with time, distance from the origin, observed in meters, that was from Tracker, predicted is from the Python program. And so plotting those, you get, or I got this result. This is the ball starting from position minus 0.328 and ending with the last usable frame 0.6 of a second later. At another point, the observed data obviously trailed off from the predicted data, and obviously that's consistent with real world experience. Every ball stops rolling sometime, and specifically golf balls, in my experience, stop rolling just too soon. Sometimes actually a lot too soon. They don't reach the cup very often. But anyway, that was interesting. That proved to me, at least I could get this far with using unfamiliar technology. But then it raised other questions. I thought, well, I wonder whether it's easy to use another component to the velocity to predict more accurately what the ball would do. And so thinking about what are the forces involved in the model, it seems to me the most obvious one is friction. Air resistance isn't going to be an issue at the velocities we're talking about. And I couldn't think of any other good ones. So friction was what came to mind, and went to a totally unreliable source, Wikipedia. and found this statement, which was interesting, which fundamentally says that there isn't going to be an easy function to apply, that there's so many different forces at work that it's basically an empirical analysis. And as I thought more about that, that makes sense too.